Electric power is very important to us personally because we use electric power a great deal. It's also very important in this course. And before we really launch into looking at electric power in detail, we're going to spend some time looking at the basic concepts for electric power and energy. In this course, we look at two major forms of energy, or two major uses of energy. One is transportation energy, and that takes up about 28% of our total energy use in the United States. The other energy resource or energy use that we'll look at in great detail is electric energy. 40% of U.S. primary energy goes into making electric energy. So this is really the most important form of energy, so we're going to look at it in this course a great deal, and here we'll look at the basics. Since about 40% of U.S. energy is in the form of electric energy, or 40% of primary energy is used to make electric energy, about 40% of the greenhouse gas emissions, CO2, is produced in the production of electric energy. So this makes this a really important energy form for this. If you look around you, or you look at your everyday life, there are all kinds of end uses of energy. So everywhere from air conditioning to electric hot water heaters to all the electronics that we use in our daily life, including the computer you may be using to watch this particular video. The guy on the left, he's using a lava lamp, and which was popular in the 60s, and you know, I just like the picture a lot, so I thought I'd show it. We want to make a real distinction between electric power and electric energy. So electric power is the rate of consuming or the rate of delivering electric energy. Electric power is measured in watts or in kilowatts. A kilowatt is 1,000 watts, so that factor 1,000 relationship is the kilo thing that you're going to have to keep track of. So a 100-watt light bulb is using 100 watts of power. It's not using 100 watts of energy. I don't know what that would mean, actually. Now, the relationship between electric power and electric energy is important. Electric energy is the amount of energy produced when power is consumed or power is applied over a certain time period. So it's always power times time. So electric energy is measured in watt hours or kilowatt hours. 1 kilowatt hour is 1,000 watt hours. So when a 100-watt light bulb is on for 20 hours, the amount of energy used is 20 hours times 100 watts, which is going to be 2,000 watt hours, or you have to divide that by 1,000, 2 kilowatt hours. Let's look at an example. I like examples. I like to do these calculations. I hope you do too. They're kind of fun. So suppose we had a 15-watt light bulb, which was turned on for 2,000 hours. How much energy is used? So see if you can do that calculation, and probably it would be best to express that in terms of kilowatt hours. I'm going to leave you a little bit of time to answer that, and then fairly shortly we'll begin with the solution. So work at this. Okay, here's the solution. I hope some of you, or many of you, were able to do this. 15 watts of power on for 2,000 hours. We take 15 times 2,000 hours, 15 watts times 2,000 hours, we get 30,000 watt hours. Divide by 1,000, 30,000 watt hours divided by 1,000 gives us 30 kilowatt hours. So the answer is 30 kilowatt hours. So the 15-watt light bulb during the 2,000 hours that it's operating will consume 30 kilowatt hours. So it's a good calculation. It's the kind of calculation you should be able to do, and you will get some practice doing that probably on the next quiz. Okay, in many of the environmental and energy things that we look at, there's kind of two bottom lines. There's the environmental impact and the human impact, and there's the price. So it's important that we realize that we pay for kilowatt hours. We pay for energy. We don't pay for power. We don't pay for watts. So if you say I'm paying my power bill, you're not really paying your power bill. You're paying your energy bill. The cost of electric energy in Connecticut is about 20 cents a kilowatt hour. So we're going to have to use that cost to calculate what it costs to produce energy that we use. Okay, with that as a background, here's another example. Suppose we take that 15-watt bulb, which consumes 30 kilowatt hours in 2,000 hours. What's the cost of that energy? So it's been on for 2,000 hours. What's the cost of that energy, assuming Connecticut electric power prices, or electric power prices, I should say electric energy prices in Connecticut. So work at that. We'll come up soon with a solution. I have a feeling you nailed that. We got 30 kilowatt hours times 20 cents per kilowatt hour. Multiply that out, we get $6. $6 is reasonable. If you made a math error, you might have got $60. That seems way too expensive, or 60 cents, which seems way too cheap. So $6 is the right answer. So that's what that amount of electric energy would cost. So, in this brief presentation, I hope that you have a good handle on electric power, electric energy, and the cost of electric energy. These are very important concepts, and they're very basic to what we're going to look at. We're going to look at some pretty profound things. How energy is produced, electric energy is produced, and how it's paid for. It's important to have these basics under your belt.